In the previous video, I described a frequency histogram which will be applied to a single parameter, and we described a central value that you could kind of get a feel for graphically by inspection of the frequency histogram. But I want to get a little more quantitative about it. So we're going to talk about the mean and the median. These are pretty easy concepts to get your head around, and I'll go over those. So the mean, that's simply the average. So you just take, if y are essentially the measured values that we're looking for, y are the measured values, and n are the number of samples, we just take the sum, the capital sigma symbol is essentially sum of all the y values, divide by the number of values, and we get the average. I think that's pretty well understood, probably basic thing that you would learn in high school or middle school. So in this case, we have 200 random numbers drawn from a normal distribution with a population mean of 100 and a standard deviation of 1. And you can see this is a frequency histogram that was constructed for that set of 200 random numbers, and the mean value of this, because it's symmetric bell-shaped curve, the mean is about 100, and it's basically about in the middle of our sample values and within the histogram. The median, on the other hand, in a bell curve or a normal distribution, the median and the mean are expected to be essentially the same. But to figure out the median is you sort the values from smallest to largest, and then you essentially pick the middle one. So what it's really telling us is that 50% of the values are less than your median, and you're going to have the other half of values that are going to be greater than the median. So let's look at a couple examples of, in this case, we're going to calculate a mean. So we have 10 samples, samples 1 through 10, and here are the measured values in the second column here on the right. And so to get the mean, we just take the sum of all these values and we divide by 10, because there are 10 samples, and you end up with a mean value of 1.12 in this particular instance. So that's pretty easy. Now the median, we're gonna, as I mentioned before, you need to sort the values. So we have the sample numbers here. The sample numbers on the left. We have the measured values in the center. These are the same measured values we were dealing with before. And then on the right, we've sorted them. So it's gone from 0.36, that's the smallest value, to a 2.27, which is now our largest value. And then what you do is you're going to find, in this case, because it's an even number, right, there's 10 values, there's no middle one. The middle value you're looking for is essentially going to be the average between the 0.79 and the 1.19. So we're going to do that calculation here. 0.79 plus 1.19 divided by 2, we end up with a median value of 0.99. Now, if we had an odd number of values, we would not have to do this calculation. We would just select that median value, the middle value. So say you had 11 data points, it would be essentially the 6th point, because that would be 5 less than that and then 5 above that. All right, I just want to point out that with an asymmetric distribution, in other words, a non-normal distribution where you may have, it's kind of a skew. Think of this as essentially representing our histogram. The mean and the median are not necessarily the same. So in this case, we call this a right-skewed distribution. It's one in which the mean is to the right of the median. Okay, and there are many distributions that in fact will follow that are going to be asymmetric, and in which you are going to observe a feature like this where the mean might be different than the median value.